remember the AC method, you take the first number times the last number. And then we need two numbers that multiply to be negative 40, but add to be negative 3 in the middle. So Maggie, how about two numbers that multiply to be negative 40, but combine to be negative 3? Negative 8 and 5. So then the AC grouping method says you take that negative 8 and 5 and you rewrite them in your problem. So you're using those two factors to rewrite the problem. And we split it up. Maggie, what do we take out of the first two?
2x.
And then out of the second two? And then the way factor by grouping works, if the parentheses are the same, that means you chose the right factors, which the parentheses are the same, so we have the correct factors. You pull the terms in front of the parentheses together, and then you group the set of parentheses that are the same together. So that's called a general trinomial. Trinomial means there are three pieces. We call it a general trinomial because it has no special pattern. But we just factor it using the AC method. The second type is called a perfect square trinomial. Why is this a perfect square trinomial? What's special about it, Holly? Yeah, the first and last numbers are perfect squares. And it's also a trinomial, meaning it's three pieces to it. Holly, do you know how this would factor them? Yeah, x plus 4 squared. That's a special pattern. So it factors as x plus 4 squared. The third one, 9x squared minus 1, is the difference of two squares. So it's no longer a trinomial. We now have just two pieces here and a difference inside. Julie, do you remember how that factors?
If you take the square of both of them, you get 3x and 1. So you have 3x plus 1 and 3x minus 1 to get rid of the middle.
Excellent. Nice. So you take the square root of the first and the second number. The square root of 9x squared is 3x. The square root of 1 is 1. And then you have a plus and a minus. And that's how you eliminate this middle number that was above. Because we don't have a middle number there. So a plus times a minus is how we kind of eliminate that, because they end up canceling. And then the last one just says a common monomial factor. That's another way of just saying take out the GCF. There's nothing else going on with this problem besides the fact that it has a greatest common factor. Anybody know what that greatest common factor is? 8x squared plus 20x. What do they have in common? Maddie? What else besides a 4? They both also have what behind them? Yeah, you're good. They have a 4 and an x. So you take out what they have in common, and then whatever's left gets written in the parentheses, and that would be a 2x and a 5. So that's called a common monomial factor. Monomial means one term. So we took out one term of the term of 4x. So those are the different ways, 4 different ways that we talked about factoring in the last chapter. And we're going to use these to help us continue to factor. We'll be factoring problems that are larger than x squared. So underneath there's a couple of vocab terms. The first one talks about a prime polynomial. So we know prime numbers have 1 and the number itself in common. So the number 7 is prime because it's only divisible by a 1 and a 7. Those are the only two factors that the number 7 has. So a prime polynomial is a polynomial with 2 or more terms. It is prime if it can be written as a product of polynomials of lesser degree using only integer coefficients and constants, and if the only common factors of its terms are the 1 and itself. Now that is like huge, wordy mess of a definition. So this is saying that something is considered factored if when you break it down, it has nothing in common or cannot be broken down any further because the only thing it has in common is the number 1 in itself. Nothing else can be pulled out of it. So if you look at the example, we have 16x squared minus 4x plus 8. How can you factor that? What could we do with 16x squared minus 4x plus 8? So just look at those numbers. What can we do to try and factor that? It can be factored. Julian?
Can you take out 4?
we can take out a 4. So Julian, if you take out a 4, what happens then?
So then it would be 4 times 4x squared minus x plus 2.
So that's the first question that we need to ask ourselves. Is there a greatest common factor? If so, we need to pull that number out. Now, using the steps that we just talked about above, mine are on my previous screen, it kind of looks like we have a general trinomial now. So the next step would be to try and continue to factor it. So to factor it, we would take 4 times 2, you get 8. And we're supposed to come up with the factors that multiply to be 8, but combine to be -1. Well, those are my 2 pairs of factors that multiply to be 8. Julian, do either of those 2 pairs combine to be -1? No. So that means whatever's in parentheses has no other common factors. It can't be broken down. So in this little blank here, 4x squared minus 1x plus 2 is a prime polynomial. Because 1 is a common factor of all of its terms, and it has no other common factors. So a number is prime when essentially the number 1 and itself can only be divided into it. An expression is prime when the number 1 and itself can only be divided into it, or it can't be factored. So usually when we say something can't be factored, then we say that it's prime. So if you say that something cannot be factored, then it's prime. You can't break it down any further. We're going to talk about factoring things completely. So we want to make sure that terms are broken down as far as they can go. A polynomial is factored completely if it's written as a monomial, one term, or the product of monomials and one or more common factors, or common polynomials. Not factored. So if you look at the example underneath, we have x plus 2, and then x squared minus 5x plus 6. This is saying that it's not factored completely because x squared minus 5x plus 6. What does that actually equal? How can you break that down further? So factoring completely means we can continue to factor and break something down. Can x squared minus 5x plus 6 be broken down and factored? Kushal, how would you factor that?
X minus 3,
So he said a minus 3 and a minus 2. So this becomes x minus 3 and x minus 2. So if I wanted to factor this completely, that means my terms need to be broken down as far as they can go. These are called linear factors. Because the value inside is only an x. It's no longer an x with a power. That's when something's factored completely. So if you have linear factors, it's factored completely. Or if it's prime and it can't be factored any further because there are no factors that go into it, then it's also factored completely. So when you look at an answer or a factored problem, that's what we're going to be looking at. Can it be broken down further, or is it as far as it can go? And then the 2 other things underneath here, you have the term factored by grouping. We've done factoring by grouping, which is kind of a process that we've used to do the AC grouping. But this is where you pair 2 terms together. And you take out their common factor. So you'll usually have 4 terms with factor by grouping. You pair 2 terms together, you take out their common factor, and then you write it in factored form. We've used that method with AC grouping. The last term I think is quadratic form. Quadratic form is that ax squared plus bx plus c. That's the form that you should be familiar with. All of chapter 4 was ax squared plus bx plus c. So today we are going to look at a couple of special patterns, and then we're just going to see if we can work through some factoring problems. So the 2 special patterns we're going to look at today are called the sum of 2 cubes and the difference of 2 cubes. So we've talked about the sum of 2 squares, or the difference of 2 squares, and that was on the previous page. So the perfect square trinomial and the difference of 2 squares. Let me see, go back up here. So these 2 right here are 2 special patterns, because they're perfect squares. So we have perfect square trinomial, we have the difference of 2 squares. Today we're going to look at special patterns that involve cubes, because we're no longer just looking at x squared terms, but we're now looking at things that are cubed. So the sum of 2 cubes, in math we refer to it as the soap formula. So think of your favorite brand of soap. Maybe Dove, because it's gentle on your skin. What Irish Springs, Dove, Dial, what kind of soap do you use? I use body wash. I don't really use soap. But think of some kind of soap that you use. So the sum of 2 cubes, the formula works. The S stands for the same sign. So if you look at the pattern, I have a cubed plus b cubed. So to get it to factor, we have a plus b. So if this is a plus, my first sign is a plus. This is a way to help us remember the signs that go in the middle. O stands for the opposite sign. So the next sign is a minus, because I started with a plus, now I need to do the opposite, which will be a minus. A stands for always, and then the P is positive. Or you could say always plus if you'd rather like to use a plus sign. So it's the same sign, the opposite sign, always a plus sign, always a positive sign. There are 3 symbols in the middle of this formula. It's a pattern, it's a formula. Those 3 symbols, same sign, opposite sign, always positive. I start with a minus, same sign, opposite sign, always positive. So soap kind of helps us reference the 3 symbols that go in the middle of the pattern. So if you look at the first example, we have x cubed plus 8. So now this works with cubes. So instead of being squares, which we've thought about for about 4 or 5 weeks, we're now working with cubes. So we have x cubed and 8. What is the cube root of 8? Because that's what the b cubed represents. So what's the cube root of 8, Odette? 2. So my a is x and the b is just 2 to kind of go along with this pattern. So the example's already started for you a little bit. It says take a plus b. Well, we have x plus 2. The second part of the pattern says take a squared. Well, a is x, so that's now x squared. Then you're going to subtract a times b, because that's the opposite sign. So we have x squared. We're subtracting a times b. Well, x times 2 is 2x. There's a minus there because SOAP says it's supposed to be the same and then the opposite, and then always positive, and the last one is b squared. Well, 2 squared is 4. So this is a squared minus ab plus b squared. So the formula remains the same. It's a space b, a squared space ab space b squared. But the signs in the middle are the ones that we kind of reference so. So same, opposite, always positive, or always a plus sign. So looking at the second one, we have 2x cubed, or 8x cubed minus 1. So we need to take the cube root instead of taking the square root. So the cube root of 8x cubed is 2x. The cube root of 1 is 1. Is 1 times 1 times 1 is 1. So then to follow the pattern, it says take a squared. So that means you're taking 2x and you're squaring it. And then always, or I'm sorry, the next one is opposite, so the addition sign is the opposite of the subtraction sign. We need to take 2x times 1, and then always positive would be 1 squared. So I just kind of plug the things into the formula so you can see how it works. When you square 2x, that becomes 4x squared. And then I have opposite, which is positive. 2x times 1 is just 2x, and then plus 1. These expressions, after you factor them, they are always prime. Which means they cannot be factored any further. So when you use the sum or difference of cubed and you factor it, that second expression is always a prime expression, no matter what. It'll never be factored any further. It'll always be prime. It can't be broken down. So I believe down below are just some practice problems for us to kind of look at using the sum or difference. So the key thing here, we got to remember SOAP. The pattern is a space b, a squared, ab, b squared. SOAP helps us to determine what goes in between the two terms. So ab, a squared, ab, b squared. That's the pattern that you're going to have to try and remember. A, b, a squared, ab, b squared. So we're going to look to see if we can try and factor these. The first one says z cubed minus 125. So the tricky thing now is to think of cubes. That's going to be the hard part. What times what makes 125? Odette? 5. So my a term is z, the b term is 5. 5 times 5 times 5 makes 125. You have a cube root feature on your calculator under math. So if you go to math in the calculator, there is the cube root feature under the math function. So if you type math, you'll see the cube root. So after you determine the cube root, then we need to plug it into the parentheses. So we have a, and then SOAP. S means same, so it's a minus sign, so I have a minus. And then B is a 5. So Z minus 5. And then A squared, well, A is Z squared. Opposite sign, so now I need a plus. We need to take A times B, so that's 5Z. And then the last one is always positive. So I have a plus sign, B squared is 25. And then it's factored. So there's nothing else that you're going to do to factor this because this here is prime. Prime means it cannot be broken down any further. So let's look at the second one. We have 81y to the 4th plus 192y. So first thing, is there a GCF? Let's start with that. GCF. 81y to the 4th plus 192y. What's one thing that can be taken out of both of those? What do they both have in common? A y. So they both have a y in common. We can pull a y out. else in common? Odette.
3.
Say it again.
3.
A 3. So Odette said they also have a 3 in common. Odette, what happens if we pull a 3 out of 81? And then a 3 out of 192 is 64. So they both have a y in common, but they also have a 3 in common that we can factor out. So after you pull out the GCF, now we need to look to see what is the cube root of 27, what is the cube root of 64. And that math feature will be very helpful. So what times what times what makes 27, Odette? And what times what makes 64? 4. So A is 3y, B is 4. And now we're going to see if we can follow that pattern. So A space B. We have the GCF of 3y. We took that out. So here's my GCF that we pulled out. Then we have A, which is also 3y. We have the same sign, and then B. So 3y plus 4, using the pattern up above here at the top of my screen. The next one says take A and square it. So we're taking 3y and squaring that. That's 9y squared. Then we have the opposite sign. And we need to take A times B. So we're taking 3y times 4, which is 12y. Always positive. The last one says B squared. Well, 4 squared is 16. So the GCF, and then my pattern, A plus B, A squared minus AB plus B squared. Questions? See if you can try and factor 1 and 2 down below here. 2 has a GCF. I strongly suggest you write your A and B terms so that you physically see what those represent. Actually, this one has a GCF as well. Anyone know what the GCF for number 1 is? It actually has a GCF. Yeah? 8. Yeah, we can take out an 8 here. So then we have x cubed plus 8. So then A is just x and B is just 2. That one's a trick. So then following the pattern, we have A, same sign B, A squared, opposite sign, A times B, always positive, and then B squared would be 2 squared, which is 4. We're going to do more factoring tomorrow. The homework is in your book. Just some factoring problems, 3 to 23, all of them on page 356 and 357. Monday, Tuesday, Wednesday, 3 days of factoring. So we're not rushing this. We're going to spend some time on the factor. Please make sure you refer to that SOAP formula as you're working through your notes.
Yep.
Yep.